Hello everyone. Um, Welcome back to again the next video of the series, and in this video we're going to talk about a little bit about timers. And I think in this particular video we're going to focus on timer on delay as well as timer off delay. So we kind of move over to our next tab, which is the timer encounters. And in this one we have timer on and timer off delay. And I'm also going to continue working on our same ladder that we had kind of created in our previous videos as well. So I'm going to go ahead and go back to the user tab, create a new rung. I'm going to create two new rungs. And then I'm going to go back to timer and counter. And what I'm going to do is I'm just going to go ahead and click on the rung, and I'm going to click on timer on. And then the next rung I'm going to go ahead and click on timer off. So what we've done is we've created a timer on delay and a timer off delay. So we ask ourselves, how does a timer on delay work? Right? And a timer on delay has several different little features to it. Before I get too far into this, I'm going to go ahead and open up the timer tab so that we can kind of talk a little bit about it. So again, the timer on delay feature has several different things that we need to look at, which is an enable function, a timer timing function, a done function, and then we can change our base. Now, I'm not sure if we can change our base on the RSLogix 1000. When we get into like the 1400 or something, or like in a slick chassis, we can change our timer base a little bit, particularly on the newer versions like a 503, 504, and 505 of a slick. But in the older versions, we were pretty much set on whatever our timer base was, which generally is about 1 second kind of time frame. Then we also have what's known as our preset, and then our accumulated, and then finally the description. So what that's really saying to us is we have different features of what we can use on the timer on delay. So if I run back over here and we talk a little bit about how when our system is triggered, so our timing has started here where our T is, and then we go up because we've become true. So we've timed out. Okay, so we'll put TO up here. So this is where we timed out right here. Okay, so our timer started. When our timer is running in this particular instance, I'll use this darker maroon red. When our timer is running, up until when it's triggered on, this is known as our enable function. Okay, meaning that the timer has power coming into it, or everything in the rung is true up to the timer. That's in our enabled function. Our timer timing, I'll use yellow for that, is going to be anything from here over to when it's done. So the minute it's done, the timer timing drops out and that goes false. And I'm going to use this lighter red here for our done. Forgive my writing here, but when it's done, it's everything from up here to the point where it's no longer enabled. So when that rung goes false and that timer resets back to 0, the done is no longer functioning. We're no longer there. Now we could also put a reset bit in there and reset it back to 0, and again our done bit would then be kicked on. So this particular thing here is how a timer on delay would work. We'd start the routine up, we'd run it in timer timing or enabled, and then when it's timed out, then it turns on and our done bit kicks on. Our enabled stays on as long as the routine's there, and then basically our output from our timer timing, which is our done bit, is functioning and on, and our timer timing functions off. So let's go ahead and kind of create the bit here itself, or the timer function itself. So what we would do is we would grab our timer data file, and we would grab this T40 as our first one, and we would drag and drop that into the timer. So this is what the actual timer is. It's putting everything into that timer file at T40. Our time base, okay, so I was incorrect on what I said, is that in the RSLogix, and this may be true right now in the programming environment, but when you go to download it may not be the same. So you're allowed to change your timer base to 0.001. So this would be the same as the Studio 5000 right here, is that it's in the milliseconds time frame. You could do it in the tenth of a second time frame, or you could do it in a full second. I like the fact that we can write it in a full second, personal preference, but Studio 5000 doesn't allow that. And then right here on the preset, we could put a tag in here as an integer. We could also do accumulate it and send it out to an integer if we wanted to. But a lot of times we'll go ahead and set this as a physical base. So for 30 seconds, this timer is going to run in the timer timing state before it's turned on to the done state. Again though, we could have set this up as an integer file and had something put into the preset file. So maybe if you had an HMI and you wanted to change the timer setting on your HMI, you could do that same feature there. So timer off delay, programming it is very similar. We just come over here and grab our timer 4.1 and drag and drop it in to place. Set your time base, and I'm going to set the preset as, we'll call it 30 as well. Okay. So the way a timer off delay would work is similar to this. However, when the rung is created as true, it's going to be on, and then when the rung drops out right here, it's going to time on, or it's going to stay on for the length of 30 seconds until it drops out, and then it'll go off. And the rung can be on or off, doesn't matter. This will stay on. Well, the rung, I already said the rung will drop out. When the rung drops out, then it will stay on for X amount of time until it drops out. So your timer timing bit will be on from here to here, and your enable bit will be on from here until it drops out, and your done bit will be on from here to here. Well, it's more like right here, when the timer is done timing out. So very similar to the timer on delay, but your timer off delay is a little different. Majority of programmers will tell you right now, stay away from timer off delays. They're a pain to work with. They'll throw you all for a loop. I've ran into this before. Timer off delays are not a standard in programming. We have them, we can use them, but they're not a standard for programming, and people usually tend to stay away from them. When using the done, timer timing, and output bits, I want to talk about that briefly. I'm going to create another rung real fast. You can use your XIC or XIO depending on what you need them for. And I'll just go ahead and create 3 of them so you can kind of see them. When you use them, you go into your timer function file, okay? And these right here are all Boolean. So enable, timer timing, and done are all Boolean, and they're all an input. They're not an output. So don't use them as an output. You're just going to drag and drop it into that, and it'll always be T4:0 \en, and that's your enable. The 0 is always going to represent, so the colon and the number will always be whatever timer you're looking at. So T4:0, T4:1. So in this case, we can use timer timing. So T4:1/TT, that's going to be your timer timing. And I'm sure you've guessed it. If we use T4:0 \dn, the dn represents the done bit. And these will all come on when these particular timers are timing in their time frame. So that takes care of timers, other than the retentive timer, but we'll talk about the retentive timer in our next series, or our next video. So anyway, thank you all for watching, and stay tuned for retentive timers.